Dear students, I hope you are all well and enjoying your online classes. Today, we will be discuss about some models of atom which describe the atom, and you are already read them from your earlier classes, class 7. Okay, but when you read atomic structure and chemical bonding, so you have to know about these things in briefly. Okay, so from your book, you can easily understand them, and I give you a brief idea about the different models of atom. So first model was given by J. Thomson and known as Thomson's model, also the resin pudding model. It gives in 1898. Okay, it was given by J. Thomson in 1898. Okay, why this is called as uh, resin pudding model? Because he assumed a round sphere. Okay, he just assumed because we just when there is no discovery, much discovery about elements and atoms, their structure, so scientists just assume them that it is a nucleus. Okay, it is a round shaped nucleus, and within it positively charged particles are found. What is he thinking? Okay, Thomson's thinking is that uh, it is like a cake like structure or pudding like structure in which positive charge are embedded with the minus charges and or negative charges, which call them electron. Okay, he called them electron, and he postulated his model like that. Okay, he assumed that these minus charges as resin. Okay, as resin, that's why it is called as resin pudding model. Okay, so he did not describe about the neutral, why atoms are neutral. Okay, why atom is neutral, he is not aware about it. Okay, so why these models have been come in existence, other models? Because the previous one failed to explain many things about the atom. Okay, so same J. Thomson's model also fails to explain the neutral, why atom is neutral. Okay, or if positive, he just one postulate is that he discovered that it is electron, that a fundamental particle of atom is electron. Okay, so now in next model comes of Rutherford. Okay, Rutherford also give his model for atom structure of atom, and he do an alpha scattering experiment. Alpha scattering experiment. What he do, you can see on your book also, and you can see here structure. So first he source for alpha particles. He put a source for alpha particles, which is a lead box. Okay, and he just bombard them. Okay, bombarding of these alpha particles on zinc screen. Okay, as you go from your book, you can see easily, and a flash of light also assumed there. Okay, is coming out due to the bombarding of alpha particles. Then how alpha scattering is occur? So you can see that when we pass through these alpha particles through a zinc screen, okay, some are the alpha particles go in straight line. Okay, 99% of the alpha particles are just uh, what you can say that just pass through this gold foil. Zinc screen is just laminate with the gold foil. Okay, that's why it is also known as gold foil experiment. Okay, then some alpha particles are rebound back. Okay, only 1% of can be deflected, or you can say deflected by some angles. You can see here that some alpha particles are reflected like that. Okay, from here also these are reflected. Okay, and a few particles, okay, one in about 2000 were uh, either deflected by a very large angle or were actually reverted back. You can see that this alpha particle was reverted back. Okay, so what he concluded after his experiment and give his model. So you can see here that this is the Rutherford's model of atom. What he concluded first is atom has a tiny dense central core or the nucleus which contains particularly the entire mass of atom. So he said that a positive charge, okay, or a tiny dense central core which particularly the entire mass of the atom, and this positively charged atom is located in the nucleus. Okay, this is the nucleus, what he say. And he said that electrons are revolve uh, around this nucleus. Okay, uh, and after that, okay, he just concluded that these things. Okay, and but what are the drawbacks of Rutherford atom? Okay, you read about the Bohr's model atom, which is now highly accepted in most areas of chemistry. Now we just go through with this Bohr's atom also, Bohr's model of atom also. But you can see in Rutherford's model, what are the drawbacks? Okay, so his bigger drawback is if we go through the Maxwell's electromagnetic theory, if he said that a positive charge, okay, positive charge is there. Suppose I make here for your understanding, this is a positive charge, and electrons are continuously revolve. So what it will do? It they just revolve like that, okay, and they comes to they lose their energy because positive charge attract them. Okay, so it loses its energy and it comes to the nucleus and collapse will be happen. Okay, so you can say that nucleus this atom will be not existed. Okay, so this not happens, so that's why this Rutherford's model of atom also failed. Okay, so now, then what happened in 1913? In 1913, Niels Bohr gave his model of atom. Okay, so what he concluded, he just do an experiment like that, Rutherford, but he said that these electrons are revolve around nucleus in a fixed direction, okay, or which he named it as cells. Okay, these orbits he named cells. So you can see here in this figure, if you see, this is nucleus and these are orbits and these electrons, okay, or you can say minus particles, okay, or these electrons are revolve around them. Okay, so he make some cells and give them name as K cell. Okay, first one K, L, M, N, O, and so on. Okay, mainly we saw till N cells. Okay, but so on also found according to the electronic configuration of that element. Okay, so from first cell N is equal to 2. So you can see two electrons are there. Okay, and if we move further about the rules of 2n square, okay, so this is the Bohr's model of atom which is highly accepted. Okay, now I just want to something discuss about your 2n square rule, okay, which you have to also read from your book. Okay, so in 2n square rule, what is said that when it comes to existence, that every cell, okay, first cell is K cell and it has two electron. Okay, so maximum number of electrons or outermost cells which you can carry is equal to this 2n square. Okay, so suppose K is equal to, if we say 2, so 2 into 2 square, it will become 2 into 4. Okay, so maximum number of electrons an element can carry in its outermost cell, it will be 8. Okay, only 8 electrons can be uh, occupied by any element in its outermost cell. Okay, and its namonate cell, okay, namonate cell means which is next to this orbit. Okay, suppose this is K cell and its nominate cell will be L. Okay, so it can be carry maximum of 18 electrons. Okay, it can contain 18 electrons. So these are some rules of 2n square. Okay, and you have to also read about something isotope and isobars, which you normally know about them very easily, that isotopes are the compounds or the formula which these are the different formula of an element which carry the same atomic number, but their masses are different. Okay, so suppose there are two isotopes of oxygen is found. Okay, oxygen 16, and their atomic masses may be different. Okay, so this is known as the isotopes of oxygen. Okay, so there are different type of you can see, sorry, there 8 will be its atomic number. Okay, 8 atomic number, and their masses are different, so they are the isotopes of oxygen. Okay, like that. So these are the some rules, and you can easily can be make electronic configuration with the help of this Bohr's atomic model. Okay, and the rule, follow the rule of 2n square. So if you have any query, you can ask me anytime. Thank you.